All right. For the last two parts of number one, C and D, you are being asked to find what are the increasing and decreasing intervals on the function. And let's make sure we get the original function up here. Well, let's show the derivative. You guys have, well, I'll put it up here. F of x equals x to the third plus 6 to the third plus 6x squared plus 9x plus 2. So the increasing intervals and decreasing intervals, the answers to 1A and 1B gave us the critical points and the point of inflection over here on the graph. And now increasing and decreasing intervals. Again, you can look at this at the graph and get the answer, but I want you to be able to calculate the actual, do the actual math and do the calculation of the situation. And there's sometimes you're not going to be having a graph to look at. And it will be a matter of being able to calculate what the situation is. Where are the increasing and decreasing intervals? So you can see increasing intervals are when you go from left to the right, it's going up. So if you're over on this side, it looks like from negative infinity, it's going to be increasing until you get to that critical point. And then if you get from this other critical point and go off to the right, it's also going off in an increasing fashion. And then in between, you notice that it's going down. So in between the interval, that's going to be decreasing. But remember what we did before. When you want to verify the mathematics of it, if you check out a number and plug it into this first derivative, let's go -4, -2, and 1 to the right would be 0. So if we plug these three values in, we can see whether it's increasing or decreasing intervals on the function. So if we plug it back into the derivative, we're going to see what the slope is doing at each of those 3 points. F of -4, we got to first get the derivative, don't we? F prime of x is equal to 3x squared plus 12x plus 9. All right, so F prime of -4 is equal to 3 times -4 squared plus 12 times -4 plus 9. So that's 3 times 16, positive 16. Well, getting a little bit careless there. Okay, so we've got the positive 16. Minus 48 plus 9 equals 48 minus 48 plus 9. That's 0 plus 9. We get positive 9. So we get a positive 9 in this first region. That's over here. And that's indicating when you plug in the -4, you've got a positive slope, and that says it's increasing. So it's increasing on that segment. Then let's plug in -2. F prime of -2, we would expect it to be negative. So we plug in 3 and plug in, -2 across the board here. We end up with 3 times 4 minus 24 plus 9 equals 12 minus 24 plus 9. That's 21 minus 24 equals -3. So we've got -3 in between here, and that's indicating that it is a negative slope in this region. Okay. And then when you plug in 0, you get F prime at 0. We end up with 0 plus 0 plus 9 equals 9. That's a positive 9. So that means over on this side, we've got positive slope also. So we've got increasing intervals, increasing on so we're talking negative infinity up until we get to the critical point, and that's at -3. And remember, at -3, it's not increasing or decreasing, so we need to keep it open. And that it's increasing on that interval and also to the far right, which starts at the other critical point over to positive infinity. All right? And where is it decreasing? Well, decreasing goes in between, so that ends up to be decreasing on -3 to -1. All right, so that is increasing and decreasing. That's part C. And now for D, it is a matter of dealing whether it's concave up and concave down intervals. So let me give myself a little room here for writing. I'm just going to get rid of this little puppy and then recognize we've got 1D. We need the second derivative. And if we take the second derivative, note if we go to the first derivative here and take the second derivative, we get 6x plus 12. which equals 6 times x plus 2. We set that equal to 0. And we've got x plus 2 equals 0 because 6 doesn't influence the 0, but 6 plus 2 equals 0. That means x equals minus 2. So we've indicated that before, that that's the critical point and the second derivative there. And if we plug in we've got the inflection point at negative 2. And if we plug in the critical points into the second derivative, we end up with negative 18 plus 12, which is negative 6, which indicates it's negative, which means it's concave down at negative 3. And if we go over to negative 1, we end up with the second derivative. We got negative 6 plus 12, which equals 6, which is positive, which means it's concave up off here to the right. So the concave down interval goes out to negative infinity and stops at the point of inflection, open interval. So 1D, we've got concave up. Concave down was what we're looking at first. Concave down on the interval negative infinity up to the inflection point, which is at negative 2. And it's going to be concave up on the interval from the point of inflection to positive infinity. All right, so increasing, decreasing, concave up, concave down, get the sense down, be able to do it mathematically as well as from the graph. All right, thank you, and we'll move on to number 2.